So let's look at this problem. It is a vertical shift of a function. It says writing an equation for a function after a vertical translation. If the graph of the function f defined by f of x is equal to x squared minus 2 is translated upward by 9 units, it will become the graph of a function h, which we would express as h of x. So I've drawn 3 tables here, because hopefully we're getting comfortable with the idea of, even if we don't know what a function looks like, we can graph it by plugging in values. And we could plug in an x value, get out a y value, and we could plot that point. So what I would like to do is I would like to label g of x. I would like to define g of x. G of x we will define as x squared, to kind of see what happened first to f of x, what happened to g of x to make f of x x squared minus 2. So if we define g of x as x squared, what would that look like? Well, if we plugged in 0 for x, 0 squared is 0. So we would be at 0, 0 here at our origin. If we plugged in 1 for x, 1 squared is 1. But if we plugged in negative 1 squared is also 1. So at 1, 1 and negative 1, 1, we start to have symmetry across the y-axis. If we plug in 2 and negative 2, they both give us 2, and negative 2 will give us 4. So you're noticing 2 and up 4, that with this symmetry, we're starting to create what we call a parabola. And it has a general shape of something like this, where it will extend up and outward to infinity, growing at this rate, at an exponential rate. So what happened to g of x to make f of x? Well, let's look at f of x minus 2. If we plug in those same numbers, if we plug in 0 to f of x, 0 squared is 0, minus 2, y is equal to negative 2. So at our vertex then is at 0, negative 2, which we see is down 2 units. And let's make sure that it's still has the same general shape. If we plug in 1 and negative 1, if we plug in 1, 1 squared is 1, 1 minus 2 is negative 1, and negative 1 squared is 1, 1 minus 2 is negative 1. So at 1 and negative 1, at 1 we're down 1, and at negative 1 we're down 1. And 2 and negative 2, when we plug them in here, 2 squared is 4, 4 minus 2 is 2. Negative 2 squared is 4, 4 minus 2 is 2. So we would go over 2, up 2, and back 2, up 2. And you see that it has the same general shape. It is the same shape. It's the same graph, except it's just shifted down 2. That's what this means here. So minus 2 at the end there means we've shifted down 2. So now it's asking us, what if we shift up 9 units? What is the expression for h of x? Well, what is it going to look like? Well, if we shift from here up 9 units, then we're just going to be adding 9. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like here at 0, 7 would be our vertex, and we can verify that. It should have the same look to it, just shifted up. And we can verify that by plugging in 0. Well, we would need to create the function first. So if we shifted f of x up by 9, well, f of x plus 9, because we're going to shift up 9, is going to be equal to, f of x is equal to x squared minus 2 plus 9. So f of x, which is equal to x squared minus 2 plus 9. And then we can figure out this is going to equal h of x. And then we can simplify. X squared minus 2 plus 9 is equal to h of x, which is x squared plus 7 is h of x. And if we look, this is just a vertical shift from our g of x. So g of x is x squared. We should just shift up 7. 1, 2, 3, 4, 5, 6, and 7. which is the same thing as shifting up 9 from f of x. And we can verify by plugging it in. 0 will give us 7, 1 will give us 8 as well as -1, and 2 would give us 11 as well as -2. So we would still be looking like that same general shape. Our final answer is what is, it becomes a graph of h of x. Find the expression for h of x. Well, we figured that out over here as we defined f of x as x squared minus 2, and we just added 9, a vertical shift, and figured out the final answer for h of x would be x squared plus 7.